Let me introduce you now to Professor Bill Keevil, who is the Director of Environmental Healthcare here at Southampton and a microbiologist, of course. Professor Keevil, can you explain to us the process, how infections are actually transmitted in a hospital setting?
Well, we know, for example, that 80% of all infections are spread by touch. And for example, a contaminated hand will contaminate at least another 7 touch surfaces if you just go sequentially from there.
So does that mean then that what the surface is made of can make a difference?
Very much so. Is the surface hard and non-absorbent? Is the surface absorbent? We know, for example, that stainless steel and plastics, hard surfaces which germs can survive on for weeks and months, whereas on copper, our research suggests they die very quickly.
So what are we going to see today then?
Well, it's very exciting. What we're showing is that bacteria die rapidly on copper. So we've set up an experiment for you where we're going to inoculate surfaces. We will compare stainless steel against copper. And hopefully what we can show you is that the bacteria will survive very well on stainless steel, but using a special dye system, we will show that they die very quickly on copper.
Well, let's get the experiment started. In a room next door, we've got Emma and Sam on their microscopes. So, Professor Keevil, tell us what they're seeing down the individual microscopes.
Well, what we're going to do is we're going to take the notorious MRSA bug, and we're going to put 10 million of the cells on stainless steel, 10 million of the cells on copper, and what we hope to show you is that they live very happily on the stainless steel, but they die rapidly on the copper.
And in theory, how long will it take before the bugs are killed off on the copper?
Well, we hope to show you that things are going to happen in 2 or 3 minutes, and certainly by 10 minutes, hopefully they will have all died out.
Let's take a look at the first picture. We're getting live feeds from the microscopes on these 2 screens. We've got the stainless steel here on the left. I don't know if our camera can pick that up there. So, Professor Keevil, just explain what we're seeing here.
So what you're seeing here are the individual bacteria sitting on the stainless steel surface. We've used a special dye which shows that while they're bright green, they're still alive.
Right.
What we're hoping to show is that they will fade away as they die on the copper surface, which will be contrary to what happens on the stainless steel.
So it's just 2 minutes into the experiment. Let's take a look at the screens that are linked to those microscopes and see what difference we can see at this point. So, Professor Keevil, talk us through what you see.
Well, you can see lots of brightly stained bacteria on the stainless steel surface.
So not much change there?
Not much change there.
Copper?
And here's the copper surface. May not look too different to you, but in fact, if you look very carefully, we're just starting to see some of the cells beginning to fade out. So these would be the first signs that they're starting to die on copper.
So it's incredibly quick.
Yes.
So we're now coming up to 6 minutes into the experiment, and let's have a look at our screens again. So, stainless steel, Professor Keevil, a lot of microbes there.
Yes, you can see they're still as bright as at the start of the experiment. So
and
no
copper?
influence. And on this one you can see they're even paler. So very few cells surviving now on the copper surface, even though we put 10 million on there to start with.
Now, what is the scientific process that's happening here? How are these bugs being killed off?
Well, we're starting to understand that copper works by multiple means, and it shuts down the cell's biochemistry and physiology.
We'll be coming up to 9 minutes now. Let's look at the screens linked to those microscopes. And this is stainless steel, and Professor Keevil still looking full of MRSA microbes.
Yes, they're still surviving very nicely on the stainless steel.
When you say very nicely, how long will they stay there for now?
Oh, they could be there for days or weeks.
Days or weeks. Let's
Yes.
look at copper.
Well, I think now we're struggling to see anything on this image, showing that the bacteria have all died off on the copper surface.
Well, Professor Keevil, thank you very much. So, from me here in Southampton University, from Emma and Sam on the microscopes, and from Professor Keevil, goodbye, and thank you very much for watching.